In this video, we're going to talk about a second method for solving a system of equations. This is called elimination. The problems themselves are still the same sort of setup. We've got two equations here with two different variables, as we can see down here in our examples. What's different is the way that the problem is structured in terms of whether this method would be easier than the substitution method, the first one we went over. So it's just another way of solving the same type of problems. So what we're going to end up doing in these is either add or subtract the two equations together. And when we do that, the idea is that we're going to eliminate one of the variables. And so if we've eliminated one of the variables, then we have one equation with one variable, and we can solve for that remaining variable. And to solve for the other variable, then we kind of go back to substitution. Once we know what one variable is worth, we're going to substitute it back in to either of the equations and solve. As far as when this is the best method to use, is we want to look at the two equations and we want to see, is there a situation where one of the variables, where each equation has one variable with this, and I kind of messed up, I think, in the wording here in the notes. I wrote the word coefficients, but what we really want is not that they have coefficients, it's that the coefficients have to be the same. So for example, down here in number 1, see how on the y we have a 7 and a 7 on both of the y's? That's the sort of situation that we want to see. So the method is best when each equation has one variable with let's do the same coefficient. And if those two coefficients have the same sign, we would subtract the two equations. So as you see on like number 2, it's both a -7, so we would end up subtracting so that they cancel out. Or if they have opposite signs, we can just add them, like in that first example. When that, or we want a situation where we can easily create that. So I do have an example with that for you also. You don't usually want to go with elimination if you have to change both equations to manipulate them into this situation. There's probably going to be a shorter and easier way to solve the equation. So here's our first example, and notice on the y's we have a -7 and a +7. So those two, if we were to just add them together, they're going to cancel out. So we're going to add these two equations together because -7y plus 7y is 0, and it's gone. As for the rest of the equation, 3x plus 4x is 7x, 12 plus 2 is 14. So now we have one equation with one variable, and that is something we can solve. So we're going to divide both sides by 7, and we will see that x is equal to 2. So we're halfway there. We now know what x is. So we can plug in this value for x into either of the equations and solve for y. It does not matter which one you pick whichever one you think is easier. Looks like in the paper notes I plugged into the top one. So we're going to replace the x with a 2, leave the y. So 3 times 2 is 6. You subtract the 6 from both sides. So we have -7y equals 6. Divide both sides by -7, and y comes out to be a fraction, but that's okay because fractions are numbers too. And we're still going to finish by writing our solution set as an ordered pair. So our x value is 2, our y value is -6/7. So that's our final answer there. In the next example, my coefficients on my x are completely different. But on my y, it's exactly the same thing. It's negative 7y and negative 7y. So if I added them together, I'd have negative 14y. But if I subtract, my y's will cancel out. Now, when you subtract, you have to be careful because I'm subtracting this entire thing. So I probably want to rewrite my equations. Nothing is going to change in the first equation. But now this is minus x, minus a negative becomes plus, and then minus another negative also becomes positive. And so now when I add these equations, 4x minus x, or 4x plus negative x, gives me 3x. The y's cancel out, and 3 plus 15 is 18. Divide both sides by 3, and we get that x is equal to 6. So now we know our x value, and we can plug back into either equation. I'm going to go with the second one because then I don't have to multiply x by anything. So I'm just going to do this work right over here since I have a lot of space. 6 minus 7y is equal to negative 15. I'm going to move the 6. Negative 15 minus 6 is negative 21. Divide both sides by negative 7. And we get that y is equal to positive 3. So our solution set are the coordinates 6, 3. So that's our final answer there. Guess I should have circled this one too. So those are our first two examples. In example 1, we added because they had opposite signs, as it says up here. Where was it? In the notes, right up here. And in example 2, we subtracted because they had the same sign on the y's. So we'll look at these next two examples, and we're going to find that it's not quite as simple as the first two. The first two were the ideal situation. The in example 3, we don't have either the x's or the y's with the same coefficient on them. And this is actually kind of going to be maybe almost like the most complicated that it's ever going to get. So I have to think about what could I change, and I get a lot of freedom of choice here. I can choose to eliminate x or I can choose to eliminate y, but I'm going to multiply each of these equations by something so that I'm creating this sort of situation that I had in example 1. So I've decided I want to cancel out the x's. So I need my two x terms to have the same coefficient, but I really want it to be like in example 1 where it's opposite signs. So what I'm going to do is I'm going to make the coefficient on the x 6, and I'm going to make one equation positive 6 and one equation negative 6. So that means I'm going to multiply this whole first equation by 2, and I'm going to multiply this second equation by negative 3. It's going to allow my x's to cancel out, but it's the whole equation, so I have to multiply all the other parts of it also. So when I do this, my first equation becomes 6x, 2y times 2 is 4y, and 17 times 2 is 34. For the second equation, 2x times negative 3, that becomes negative 6x minus 15y equals negative 78, I believe. Yes. Okay. So now the x's are going to cancel out. They both have a 6. One's positive, one's negative. So all I have to do is add these two equations together. X's are gone. Positive 4y plus negative 15y is negative 11. And 34 plus negative 78 is negative 44. Now I'm down to one equation with one variable. So once you get the two equations added together, it's not any more complicated than the first two examples. It's just this extra step here in the beginning, allowing for one variable to cancel out. Divide both sides by negative 11. And so negative 44 divided by negative 11 is positive 4. So now we know what y is. We can actually plug in, we have 4 different options of where we could plug that value of 4 into. You can choose one of your original problems, which is usually going to be the best choice because in that you have smaller numbers. We tend to do a little bit better when we have smaller numbers. We can do things quicker and in our head. But you could have used either of these two equations that we transformed. I am going to do what I did in the notes, which means it looks like I used the very first equation here. So I still don't know x, but I know that y is 4. So this becomes 3x plus 8 equals 17. Subtract 8 on both sides. So 3x is equal to 9. Divide both sides by 3. And we get that x is equal to 3. So our final answer are the coordinates 3, 4. So this is about as complicated as it's going to get, just to let you know. All right, over here in this equation, I don't have any coefficients that are the same, but I am noticing that if I multiplied this first equation by -2, I would be able to do some canceling out here. So I can easily turn 3 into -6 by multiplying by -2. So this is going to become -6x minus 8y equals -48. I didn't have to multiply the second equation. I just got to copy it down. And this is another one of those unique situations because what happens when I add these, the 6's cancel out. I mean, sorry, not the 6, the x's cancel out. The y's also cancel out. And so I'm not left with anything over here. So if I don't have anything, that means I have 0. And then -48 plus 24 is -24. Well, -24 is not equal to 0. Those are two different values. That is not a true statement. So this is no solution. That's not always going to happen when you have to multiply only one equation. That was just the unique setup of this particular problem. So sometimes you might just multiply one problem and then you would proceed like we did in example 3. But I wanted to give you another example where we ended up in those special situations where all the variables cancel out. Now that you have finished this video, you can begin working on either the mild or the medium assignment from the second row of the choice board. I still don't want anybody starting on the spicy. Those problems you need to have practice with all the methods because you're going to have to decide which method is best. So at this point I want to make sure that you understand how to do elimination. So choose the mild or the medium, practice with this, and then when you feel ready, come take your mastery check.